If I've got a robot in my house that doesn't respond in milliseconds, I might have a dead cat who I really loved. I really loved that cat. And the robot accidentally ran it over or basically mowed it up. Or if I'm building something of high precision, I just need to be able to have time series based resolution of what's happening.
This is DevOps Paradox, episode number 337. Nanoseconds matter. InfluxDB and the future of real-time data. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darin and Viktor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darin reading this text and feeling embarrassed that Viktor made me do it. Here are your hosts, Darin Pope and Viktor Farsic.
Back in episode 335, we had Peter on from Co-Root, and Viktor, you brought up a point that, especially in observability, in the old days, we would keep more recent data and we would start aggregating older data just to save on cost. Do you still agree with that?
I do. I do agree with basically not keeping things that you don't need. Be it in software or, in your house. Doesn't matter.
So it's going to be interesting how we take this today, because coming from our primary world, we think in seconds and maybe milliseconds, right? That's not a big deal, because you think about Kubernetes responding or waiting for a Jenkins build to finish up. It's like, okay, who cares? It's not that big of a deal. But
can I be mean for a second?
Okay, sure.
Jenkins builds never respond in seconds. So you don't need to worry about that one.
Okay. I still work with it. Come on, give me a break. I could say something negative about your project too, so let's not do that right now. No, I won't do it now. But let's assume this for a second. What if we're waiting for a car to stop? Do you think we could wait seconds or milliseconds for it to respond? Or maybe a manufacturing arm, a robot arm moving things around? That seems like it would be a bad thing. On today's show, we have Evan Kaplan on from InfluxData. Evan, how are you doing today?
Good. How you guys doing?
Good. I heard you snickering in the background a little bit about some of the earlier things, but what do you think about the car and the ARM thing? Because to me, when we call it real-time data. I think there has to be a better phrase to it than real-time, even though that's what people still call it. What are you seeing, and how do you think, because Viktor's context, because in case you haven't listened to the episode, it was around, used to we could throw data away. But now that we have AI, we want as much data as we can. So it can potentially help us make some better choices. But in the examples I was just bringing up, we're talking about making a choice now. Like if we need to shut an arm down because it's getting ready to blow a bearing or something. What are we thinking about these days?
So you guys share some background with me in that you're not new to this industry. People have been talking about real-time forever. RTOS, operating systems, just, the narrative. Nobody knows what real time is. I'm not sure it's an important distinction. I'm not sure it matters. I'm not sure the label helps. Of course, we use it in our marketing. And so we use it because it signifies some broad concept that at least things don't have ridiculous amounts of latency. That's about the utility of the term. But let's ground, since you started with the little bit of the controversial, or not really controversial, is that car, that robot arm, that dynamic is, we're clearly moving into a physical world of increasing automation. And if you look at sort of the backdrop of the universe, if you think the counterforce is entropy, then you think the force against entropy is consistent organization. And for us as humans, that means increasing automation. Building systems that are self-healing, self-adapting, eventually completely autonomous. That's where we want our systems to go. They don't all need to be there. They certainly don't need to be there tomorrow. Some of them are highly useful, like the self-driving car when it gets there. But that's the journey that all these systems are on. And so when you talk about microsecond or you talk about observability data, which most people are happy every second, not particularly useful. If I've got a robot in my house that doesn't respond in milliseconds, I might have a dead cat who I really loved. I really love that cat. And the robot accidentally ran it over or basically mowed it up. Or if I'm building something of high precision, I just need to be able to have time series based resolution of what's happening. The higher the fidelity, the higher the sampling rate, the more fidelity I'm going to have and the better picture of the real world I'm going to have. So let me not go on and on here. I took a little thread and I took it forward, but tell me where you want to go with this.
When we talk about getting quick responses and what's not, wouldn't the logical direction then be direct communication, no intermediary at all? I mean, I know that's not feasible, but if somebody wants fast something, then just remove anything in between of those two endpoints.
That would be great, except you want to build intelligence. And intelligence ideally can be resident at whatever the endpoint is, but isn't always available at the endpoint. And the nature of pipelines and data, doesn't often allow that, right? And then you have just, like these are just electrons moving through space. So simultaneous, is a little bit challenging. But I think you're right. The least impedance is the most beneficial for if you want real time.
Isn't sort of the gold standard for real time a human? Or you would hope so, at least.
Even we are not. You could be real time only when you change the rules of the speed of light, make it instantaneous.
Okay, but it depends. So self-driving cars. Let's stay there for just a second. As a human, I still don't trust self-driving cars. I won't get in a self-driving car.
Well, as a human, I don't trust other humans driving cars.
Well, that's what I was going to say as well. So
it's all a matter of risk.
It's all
a matter of what risk you want.
Yeah, my premise, I guess, is falling apart. But it seems like, so we have time series data. Let's play this out for a second. We have time series data coming in. How long do I need to keep the time series data?
Depends on the problem you're trying to solve. Depends on the fidelity you want. It depends on what you want to learn from it. So it's very common. The most common time series use case is I collect really high resolution data for short periods of time, and then I downsample it and store it for long periods of time. Anything that would give me the signal I need and separate the signal from the noise, that's the period you want to keep. Now, if I want increasing fidelity and incredible intelligence about the physical world, I'm going to keep more data that's more descriptive. Let's look, so maybe an easy metaphor for you is a photograph, right? Do I want a 2 megapixel photograph? That works fine for 98%. I'm showing it on a screen. I'm showing it on my thing. Or do I want, an 18 megapixel photograph that allows me to locate the tiniest portion or pixel on the image? Like, it depends on your utility. My theory is that we want increasingly high resolution data to instrument the physical world, that we're entering a very different world with physical AI. And so it's not okay for the car to respond in 1 second. The car's got to respond if it's moving at 60 miles an hour, and we can do the calculations. We're not assuming a car's moving at the speed of light, but we're assuming the car's moving at 60 miles an hour. It's got to respond in some significant sub-second time to things that interject itself in its path. This is the world we're going into. These factory arms, think about the manufacture of a semiconductor. Precision, accuracy, pattern, like this is all, we're talking nanometers, nanoseconds. We're talking high resolution. This is the world we're going into.
Is nano now the true second? Because used to we would think about milliseconds, right? We would thinking websites or any kind of response times from disk. We were thinking milliseconds.
Depends on your system. Our default period is nanosecond. Very few people use it. Some of the quantum computing customers we have use it, but our default is nanosecond. So if you want to store it nanosecond, you can. It's expensive, as you'd expect.
I guess that the answer to that question is whatever you need and not more granular than that. Or not faster than that, right? Because the moment you go above what you need, you're paying for it. And not only in money, but also in performance in many different ways, right? If you would say 10 milliseconds for the car is ideal, why would you go for 1 millisecond? I'm not saying it's not better, but if you say that's the kind of, I don't need more than that. Or why would you have an infinite amount of pixels in a photo that you're going to show on a mobile?
So if what you're saying is fit for purpose, of course, I totally agree. The question is how does the purpose change, right? My initial thing is I just need the photograph to show on a thing. It turns out it's a piece of evidence in some sort of murder case, and all of a sudden I want a high resolution to capture some tiny. Anyway, I mean, you get the simple idea is I don't always know a priori what that period is. Of course, I should make some estimate, put a range in it, and do it, which is what most people do.
The tricky part I feel is that you don't also know what will your needs be in the future. So if you go back to my photo example, right? Let's say that my mobile cannot show more than 1 megapixel photo, right? Maybe it will tomorrow. So do I over-optimize for that tomorrow that I don't know what it is? Or what do I do, right? Do I pay today for tomorrow?
What did you do when you rented your apartment in Barcelona? Did you plan on having 3 more kids and a family? And so, you make these judgments.
Yeah.
I think the really important point here, guys, to pull out is that we're in an age, and you guys have been around this sort of infrastructure for a long period of time, where you've gotten these really quality specialized tools on the data side. And, it started years ago with document data, search data, graph data, time series data, vector data. You can get more efficient. You can get a purpose-built stuff that actually solves significant problems. And so the tool set you have is just so much wider. It's as if before you had a hammer and a screwdriver and you were going to build pretty much everything. But now you've got a full set of tools that you can work with. That's the change in the world that I think is important. It doesn't mean you should have a full set of tools for every job, but it just means you have those tools available. And I think that's what's changing.
So in other words, there needs to be a Home Depot or a Lowe's right down the street from where we're working. So if we need a new tool,
or virtual one.
Yeah.
Or a virtual one. That's instantaneously available.
That's instant, right. I want to nerd out for just a second, or at least to me it's nerd. You were saying nanosecond is your base time series or time second, whatever. How do you even have hardware that can write to that fast, keep up? That seems very odd to me. And you said quantum. Okay, sure. But I can't go down to my local micro center. Rest in peace, fries.
Actually, I don't think the hardware needs to catch up. I don't think it's capturing every nanosecond, but it's breaking up the data it captures in nanoseconds.
Yeah.
Reads.
Okay.
So, because, But the idea is, how do I want to store the data and if I want to capture it in this?
Where do you think this whole AI thing is really coming into play? I mean, there's always been machine learning for decades. I mean, obviously the generative AI is sort of the new kid on the block, has been for a couple of years. But is that really helping us? Is it hurting us? Where's that going?
Remove it from those cars you're afraid of and let me know how it went.
I can't talk about, there are the people way smarter than me about the broader implications on society. I could opine on it forever. We all have our thoughts. I'm not sure I'm the useful guest for that. But in terms of generative AI, I find it amazingly useful. Our coders find it amazingly useful. I find it in my personal life amazingly useful. I just think it's a main tool. It's not what we do. I'm much more interested in deterministic models of the world rather than probabilistic models. For the digital world, for data, for language, probabilistic models work just fine. But for the physical world, you need deterministic models. Again, I don't want my robot to run over my cat. It's pretty simple. I don't want my self-driving car to hit the pedestrian. And so I don't want probabilistic models. I want deterministic models. In the generative world, we're collecting digital data. And that's pretty much all collected. And it appears every day. It's rescraped. You get new data every day. And now they're building synthetic data to make their models. In the physical world, the amount of data you can collect is by definition infinite. By definition infinite. Tell me the system you want to build. I'll tell you the period of data to collect, the amount of data you want to collect to train the model, and then you can collect it. That's what's new. We can build models of the physical world that actually are quite deterministic. It's not new, actually. It's happening. It's been machine learning. It's just accelerated.
Well, I think that's where time series really does come in because, we've had time series data stores in the past as well. But that's really, to me, better than a relational database for building out models.
100. No, it's not even close. So if you built this thing 30 years ago and still exists today, there are time series applications running on Oracle today, right?
Yeah.
If you built it 20 years ago, you ran it on MySQL. Maybe if you had 15, you built it on HBase or something like that. It's only in the last 5 or 6 years that people have built really meaningful stuff on dedicated time series platforms. Satellites, self-driving cars, battery power systems, energy management, alternatives. The app, now that you have a specialized tool, you can get that resolution, be less expensive, and to be more responsive, which is where all these systems have to go over time. No pun intended.
Why did time series need to exist?
Because as you started using the general purpose databases, relational databases, MySQL, Postgres, you realize that you're just not optimizing for, if you know your vector of search, you know your index is primarily time, you can change your ingest level, you can change the time it is to write, you can change your query time and query speed, you can change your cost of storage if you specialize. If you don't, you pay all the prices by not specializing. If you want to take your minivan and you want to race in F1 series, it'll be fine. It'll go around the track. It'll do what it's supposed to do if you don't get run over.
And you're guaranteed to come in last at that point too. But could you imagine a minivan riding around the Las Vegas F1 track? That would be.
I'm sure somebody's outfitted one to do just that.
Now we're entering into the discussion of, all-encompassing databases like Elastic that actually are trying to be, not everything, but all-encompassing, at least within an area, logs, metrics, traces.
Well, that's that whole space. That's the whole space. They all want to be the melt stack. They want to have metrics, events, logs, and traces. And so Elastic is one of them. But there are 30 others.
But that almost feels like inevitable is a wrong word because it's obviously evitable, but I'm going to keep using it. Inevitable expansion of companies, right? You find your niche. You say, I'm very good at logs. Where do I expand my business? To metrics, right? How do I do that? By modifying what I have.
You build a tool. It's useful. Splunk did this before Elastic, right? You build something, you build a tool that's useful, and you figure out how else you can use it. That's just capitalism. That's just, how do I leverage my adjacency? You'd expect vendors to do it, but you'd also expect customers and architects like you to be very picky about what you assemble as a solution. And that sometimes a one-time fits all makes a lot of sense for you, right? Just a simple MongoDB, they claim to do graph, vector, time, everything. Maybe it's good enough. I don't know. You got to figure out as a developer or an architect, what is the thing you're building and what do you need?
When InfluxDB specifically was created, you weren't around for that. You came in a little bit later, right?
Yeah. I came in pre-revenue, but there were 3,000. When I joined, there were 3,000 instances in the wild running daily. Today, there are 1.4 million that run daily. And so pretty early, but I'm not a founder.
So you were in early enough. Why did the founders even decide to create a time series? Was it they just got bored and decided to, let's go do this weekend?
Like most good businesses, it's a pivot. Like most of this stuff, it's a pivot. My partner, Paul Dix, the founder, he had worked on Wall Street. He had built a lot of application code on top of existing databases to do financial trading for different firms. And so he had that experience. But he didn't go right there. What he did was he tried to start something like a mini Datadog, a simple cloud-based, in those days we didn't call it observability, server monitoring platform. And he realized that was going to be a big lift and he'd have to raise a lot of money. And he was deeply convicted about open source. And he wanted to work on an open source thing anyway. And so the database that he originally built to collect the metrics and events for that cloud-based service, he then open sourced it. He wrote it in Go. He open sourced it, and it became immediately popular because it handled the 4 or 5 things that I mentioned. It had amazing ingest. It had super fast query time. It had the ability to evict data very fast for downsampling and resolution. It was cheap to store the data. So he solved a set of problems that if you were a developer, you'd have to go solve on your own if you used Postgres or MySQL which it would have been the state of the art at that point. It was just really one of these organic popularity things. And it was helped that it was originally a Go project. Go was early and Docker had just come out. And so there was a really interesting time for Go. But mostly it was just really super easy to use. People get started right away and it was powerful.
It's interesting you bring that out. So I'm guessing that was around 2011, 12.
13. He started in early 13, made the first commits, I think, publicly in 13.
So we're talking 12 years ago. That was early Go. I mean, early. Yeah. That predates even Kubernetes, Victor. Is that possible?
Yes, it predates Kubernetes. I hope Victor doesn't get insulted by that.
No, he won't.
Oh, I've been around.
That's actually pretty interesting because do you think it was probably one of the first major projects that took on Go?
It was a very early project. I think Docker preceded it. I don't remember. There's some other really interesting projects, but I don't actually remember since I came to the company. It was not really a revenue company. Yeah. I came in early 16.
So what's it been like from 16 to now 25?
It's been...
okay. We've had a lot of things happen over these past 9 years.
Well, I was young. I had jet black hair, and now your audience can't see me, but I've got gray hair. And it's actually been a really nice run. I really love working on open source projects. We have chosen to keep it a promiscuously licensed, which is really, that's become almost controversial these days, is most of our competitors have gone to these secondary licenses. So we kept it MIT and Apache. We have a really vibrant OSS community, so that's been feeding. And the business has grown consistently and nicely over that period of time. And so we're now of a size where we can really continue to, build something of significance.
If you would start it today all over, would you still keep it MIT?
This is a debate between Paul and I. I think I would. I would. I think we've taken, our approach is really open core. We're committers on Apache Data Fusion. We're committers on Apache Arrow. So we're very much involved in the whole stack. And we make contributions to the open source, not just our own project. And so it's one of our core values is we're deeply committed to open source. And I think the right method for open source is we just don't put everything in the open source, right? Yeah. That's just it. We're open core, really.
To be clear, I'm an open source person completely. It's just that I can see certain concerns being raised, whether this system actually works for new players. I cannot prove it. I can feel that some new startups are learning the lesson and not necessarily correctly learning the lesson, but saying, okay, maybe this is not actually beneficial for me starting today in a way, right?
I still think it's very beneficial, particularly for infrastructure. And I help out other open source companies, and I'm pretty committed to the whole ecosystem. One of my advisors is Ali Gotzi, who's the CEO of Databricks. And Ali said something I thought was very wise, but not so obvious. The problem with open source is you have to hit 2 home runs in order to even be in the game. First, you have to have a project that is interesting, popular, that people want to engage in, and that for those guys, that was Spark. The second, maybe even harder, which is to figure out a way that it makes sense to monetize it and to keep a lead and to keep yourself as the primary player in that space. So look at where that's failed a little bit. So Redis is probably the 4th largest provider of Redis. Elastic is definitely the 2nd largest provider of Elastic. HashiCorp may increasingly becoming the 2nd largest provider of, IBM may be the 2nd largest provider of Terraform. We're a little bit different as we continue to be the largest provider of Influx or other third parties. And I know the question you're going to ask, but haven't asked, which is, what about the hyperscalers just taking your code and running it like they did with Elastic or they did with Redis and they did Kubernetes, but, Google contributed Kubernetes, right?
Correct.
And so we have been, I don't know if it's lucky or whatever, but we have been very lucky in that, Amazon runs InfluxDB. And they pay us, and it's a very good business for us, and they're an amazing partner. That's not what happened with Elastic. It's not what happened with Redis. It's not what happened with a lot of open source projects. I think they have set the example with us in the last 2 years that it's better to partner with these open source vendors and build your own development teams, fork it, do all this other stuff. And that's been a really generative thing. So hopefully what that does is the next startups who do open source, they don't feel like they have to close off their licenses. They don't have to have infections, copyleft licenses. They don't have to do what Mongo did and Elastic did and these other companies have done. So because the community, and you're an open source guy, so if you build a good community, you got to have a good chance of monetizing in some interesting way.
I'm not sure that I would say that you have a good chance, but I would say that in certain areas, you almost stand no chance without getting that initial adoption, right?
Right.
I mean, there are plenty of, I could say that compared to what it was, Docker is a failed company commercially. I mean, they're doing well now, but compared to...
For a totally different use case almost.
Yeah, exactly, right? I do agree, assuming that that's what you meant, that actually the second stage, making a commercial successful product on top of open source might be actually even more complicated than open source, well-adopted open source itself. But it's also that there are areas where simply you don't even have a choice. Like today you can easily create, let's say, model-based company for LLMs and say, I'm going all closed source, perfectly valid, right? But if you try to convince people to use, let's say, infrastructure as code, given such a high competition in that area in open source, you basically, there is no choice. I mean, or there is illusion of choice, right? But you will never succeed.
But that's part of how I got into this. So I'd been an infrastructure guy, mostly security and networking, and I was running a public company, and we had a lot of Oracle, and we replaced a fair amount of it with open source Mongo. And then, we built some big data pipelines based on, Hadoop and other stuff. And so I saw the power of this stuff. I thought it was inevitable. And I think it is. I think in certain sectors, having a closed source product is a non-starter.
I mean, I would go as far as to say that if Oracle started, let's say, later, I don't know how many years, but later, it would never become a company by being with the licenses that they had. They were just lucky to start. Not lucky, but they started early enough, right?
Yeah, you try to fit your times.
I want to ask a clarifying question of something you just said there. You said you were the head of a public company.
Mm-hmm.
You were building things around Mongo and whatever the second thing was, I forgot.
Hadoop, the big
Hadoop,
data
thank
infrastructure.
you. Yeah.
We were trying to assemble that. One was successful. One was really freaking hard.
I'm guessing Mongo was really hard and Hadoop was very simple.
No,
right?
other way around.
Yes,
the data.
I'm joking.
You were joking.
Yes.
Oh.
Yes. How important was it to you back then to make sure you were contributing back to those projects as they existed at the time?
That's a great question. It was not important at all. It's terrible to say it was not important at all. As a CEO of a company, it wasn't important at all. Now, if my people wanted to, I would be, because they wanted to, I would totally be supportive. No issues. I wouldn't block it. I'd be supportive. But it just was not even on my radar.
Can I make a guess of why that is?
Sure.
Here's something that's free I can take off the shelf. It doesn't cost me anything in money. It's going to cost me some body time. But it's going to get me a lot faster, and I don't have to pay anybody a single penny. Is that the thought process of a CEO?
That's right. That's right. But I would tell you, this was 2012 or something. I guarantee if I was running that company today, I'd be paying MongoDB. Because I'd want all the support, the added features, the stuff that they've added above the open source. Maybe I'd want to run it on Atlas because I'd save a bunch of money. So what Mongo did that was so successful is they figured out the way to monetize it. I'm a little biased because the CEO of Mongo, the former CEO of Mongo, is now on my board. So
let's be careful here. Let's be careful.
No, it's no issue. It's no issue. Is they started by selling support contracts.
Right.
Support contracts are ephemeral. Once I realized I got 2 support incidents a year, why am I paying you $20,000 for my 2 support incidents a year? I'll figure this out. But if you give me a service or if you give me added capability, I'll generally pay for it. It's still going to be a lot cheaper than Oracle. And they have less lawyers.
But that's human nature, kind of. Why would you invest work in something that does not benefit you? You will notice actually that companies running at massive scale, they are more likely to contribute simply because their systems might not contribute because they're nice people or none of those things. I mean, individual employees, yes. When I say contribute, I mean as a company policy, but because we depend on this. If we don't put this into the project, we are toast. And we are one of 5 that actually need it.
That actually happens all the time. But we have a project that's even more popular than our database called Telegraph. We get tons of contribution to that because people want different connectors, which Telegraph's a connection system, different connectors to be compatible. I think there are 300 plus of these things out there. People contribute all the time. You can count a little bit on altruism, but you can't carry too much on altruism.
Let's face it, and this might be harsh for what I'm going to say, but most open source maintainers are not doing it for altruism, right? They're also getting paid by that company, right? Everybody does it for some selfish reasons to begin with. Well, not necessarily everybody, right? There are weekend projects, but I'm talking about serious dedication.
So we have an employee who's phenomenal, and he devotes almost his whole time to being the PMC for a big Apache project. And I will tell you, we pay a salary, and we use that stuff, so we're willing to do that. And he's also an amazing person. But I will tell you, he builds it because he's proud. He's just proud of building a really cool Apache product that lots of people are using. I mean, those were the original reason people became software engineers.
Oh, I have zero doubt about that. I'm just trying to say that he's still getting salary in a way to work on it.
Oh, he needs to eat.
You are giving... Yeah.
He needs to eat.
Exactly.
Yeah, would he be doing it as much if he just had to do this all on his own time? It'd be hard.
Yeah.
He probably couldn't.
Would he live scraping by, doing some odd part-time jobs so that he can dedicate every single minute he can of the rest of his time to that for pure altruism? Probably not, right? That does not exclude pride. I get paid for much of the work I do, and I'm also proud of it, and it's open source. Great.
I think it's thriving. I think promiscuous license will continue to thrive. I think amazing things have been done on the Apache frameworks, obviously. Linux, Kubernetes, all the Apache projects. Like, this is our infrastructure. This is it.
How big of a deal are the foundations now? Rewind back to your 2001, right? There were effectively no foundations. Linux Foundation might have been around then. I can't remember.
Yeah, I don't know, actually, when Linux Foundation started. I think they're important. I don't end up engaging much with them, but sponsoring these projects, I think they're all pretty useful. Are they game changers? Should they be highly profitable businesses? I don't think so, but they're pretty useful.
Well, that sort of goes against the concept of being highly profitable and being a foundation, but that's a whole different conversation.
It happens.
Yes, it does.
Oh, yeah. I think that the question should be the other way around. I don't think that actually, this is my personal belief, that foundations are that beneficial for you as a company behind the project. But it is very beneficial for you as a user, because then actually project is in a foundation. You cannot do a rug pull of the license or, do some random stuff. At least not easily. You can. It's literally impossible, but makes users are slightly more protected, right? Those that don't want to get commercial version.
Yeah, as you said, they're not going to get the rug pulled out generally if it's a Linux Foundation or Apache project. I can't imagine how you'd pull the rug on an Apache project, but yeah.
I want to go back to your mention of your partnership with AWS because it sounded interesting to me. You said they're paying you, but are they paying you for your commercial product?
Yeah, both. They pay to license our open source and run it, and then we offer our commercial product on their platform. It's called TimeStream for InfluxDB. It's pretty much the same as InfluxDB, but you could just buy it directly on Amazon. And we have a good commercial relationship that works for them, works for us. And by the way, they worked hard to build that. They did a really good job with us. Because as you suspect, we were a little bit like, okay, we've seen what happened with you guys in the past. But that is not the case here. They've done some really good work.
When you look at yourself, Influx, and let's say some other extremes, was it in your case pure luck, or that's a strategy, or how you approach things? Kind of like, why didn't AWS do the same thing as with elastic?
I think there are a couple of reasons. One is you're now, they probably made that elastic decision close to 10 years ago. And so now they've seen, you'd have to ask them, but now they've seen what it takes to maintain their own fork of all this sort of stuff. They've seen what it takes to have a Valkyrie version of Redis. They've seen that this is expensive and their customers want fast returns or other stuff. And so all of a sudden they're a big development operation when maybe they don't need to be, right? Maybe they could cultivate relationships with vendors. They can get the workloads on their platform, which is most important. And then when the workloads are on their platform, now you can use so many of their services, SageMaker, Redshift, Lambda, and integrate and use those tools. As you guys know, data has gravity. So if I can get data on the platform, why would I have any impedance to getting data on the platform? Within reason, why wouldn't I just get as much data on the platform? And this, particularly time series, was, and I say this humbly, we're the clear leader in that space. People have been asking them to run Influx, even though they had their own product. And so it just fit. It was just good. There was a change in how they thought about it, and we happened to be there. And we had customers who wanted to be on AWS with them. It just worked.
I was more hoping for some words of wisdom, kind of, because I did this and the others.
I'm genius. No, it's because of me. As you can see, because you can see video, I'm just a handsome, debonair executor that they couldn't resist.
Let me flip it around to something we haven't talked about at all. Okay, we've been talking about time series. Somebody's listening now. It's like, I need to do some of that time series. Who doesn't need time series?
Great question. I think if you're doing some sort of instrumentation, it's light work. You're not super worried about the operational nature of it. You might be posting some dashboards or things like that. You could easily use one of the observability vendors. You could easily use a general purpose database. You can do that if you don't care about that. The people who do need to use it are people with operational workloads. People not only who have dashboards, but have things dependent on it. Like they've got huge amounts of data. We have a customer, Ninja One, has 10 million devices out there collecting at regular sampling rates who are, looking for security events. We have other customers in security space. Like you need an operational platform. You don't need an observability. You need operational. You don't need analytics as much as you need, I've got to be able to, I've got to have zero time for the data to be read. I have to be able to act on the data in less than 50 milliseconds. Like those are the people who need it. Other people, they could spin up SQL Server and do fine. We have a huge group of home users, believe it or not, because the open source. So we have just people who instrument their thermostats, their pools, the different sensors around their house. And there's some incredibly cool projects. We don't monetize that at all. And occasionally we have a home user who brings us into their corporate job, and that's great. But it's not what we count on. I think you guys should actually become home users. And then we should do this whole process again.
I'm already a home user. I use my home very frequently.
Well said. Well said.
Can you define huge amount of data? Because people throw around huge amount of data. What is a huge amount of data?
It depends. Petabytes of data. It's more about how much you're writing simultaneously than what's collected, because what's collected over time is huge. But, can you write 1 billion points simultaneously? How many devices at the end of it? I'm sure I can get to you guys some of the bigger projects we have and share with you. But
okay, so petabytes.
Yeah.
So no exabytes that you've seen at least, or at least none that you can speak of.
Yes, I'm sure there are. We're not talking about it. I'm not. Probably forbidden to talk about that particular stuff.
It would be, government 3-letter companies that would have that kind of stuff. But hey, we won't get into that either. Anything else that you've been in this space for a long time. We've sort of jumped all around. Anything else you want to talk about? Just
no, only that if I could get one message across to your audience is there's times and places for developers to start with a time series database and not just use the database they've always had or something they've spun up, a fast Postgres or something like that. And that's when they're reading, often it's when they're reading either virtual or physical sensors, and they know that over time, the amount of data they're going to be working with is going to be both expensive and needs to be performant and needs to come in. Our stuff is easy to start with. It's incredibly, it's schema on write. It was sort of modeled after Mongo, to be honest with you. Mongo, if you remember Mongo in the early days, was their brand was easy to use, easy to get started versus your standard relational SQL database. And we very much have built on that brand. Time to awesome is relatively quick and scale is pretty amazing. So just know when a developer should start with it. That would be the most important thing.
Sounds good. So everything InfluxDB can be found at influxdata.com.
And GitHub.
And GitHub. And that's what I was going to ask is, do you know what the home project is for InfluxDB?
I think it's InfluxDB.
Okay. Yeah. So it's InfluxDB/InfluxDB.
Yeah.
Or
give us a GitHub star if you like it.
There you go.
Because we still like stars. Even though we're north of 30,000, we still like them.
Okay. So why do stars matter to you? This is a hot take, probably.
It's a little bit of pride, like all these people, these people after TED, projects, listen, open source projects, if they don't have velocity, they die. And so I'm always looking at the rate of change in stars. And so if stars continue to go up at a nice rate, and people can see that we're continuing to add, we're continuing to work. I think if you would ask Paul, my founder, he'd like to have a database like Postgres that's 40 years old or whatever. We have some pride in that. So independent of the commercial instincts.
So we can come back again in, 25 years? Would that be about right? No. 30 years. We'll see how many stars. Yeah.
As they say where I'm from your mouth to God's ears.
Yeah, 30 years from now, that would be, let's see, do the math, that'd be 90. That would be about right. And you should have at least 100,000 stars by then.
I'll be almost 40 by then.
Wow. That time series database really does interesting things with math. That's all I can say.
It transformed. We have transformers in there.
Transformers. Right. Again, everything about Influx can be found at influxdata.com. Again, open source at GitHub. Evan, thanks for being on the show today.
Hey guys, thanks for having me. It was a real pleasure. Enjoy Barcelona.
I will.
And keep using your house.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.